I'd like to just acknowledge the town hall from this year. We've had some great town halls. You might remember on the very important topics of early and mid-career researchers and what we can do to support early and mid-career researchers generally, but specifically here at TRI. We had a wonderful town hall on reconciliation and TRI's RAP plan, and just rounding off this time with the clinician researchers. The first town hall of next year will be of interest to everyone because it'll be in regards to TMI at TRI. So the Translational Manufacturing Institute, which as you all would know is the new building to be built at the back here of TRI. So I'd like to introduce our first speaker, and it's really nice to introduce Professor Scott Bell. And I do have his bio in front of us, and I'd like to go through it with you because we don't often do that for the CEO at TRI. He's often introducing everybody else, but it's really important because our speakers here today are to talk about their research journey. So Scott, as we all know, is the Chief Executive TRI, and he's also a senior physician of the Adult Cystic Fibrosis Centre at the Prince Charles Hospital, and he's been there since 1996. He's a clinician scientist and he leads the lung bacteria laboratory at UQ. Scott has more than 290 reviewed publications, has received more than $24 million in grants. His research interests include acquisition and transmission pathways for human infection, and his multidisciplinary research has resulted in significant changes to clinical practice and policy implementation globally. He's been a principal investigator on numerous pivotal CFTR modulator trials. He was the editor of the Journal of Cystic Fibrosis from 2013 until 2020. It's my pleasure to introduce Scott. Thank you.
Thanks, Helen. It's embarrassing when you hear about things said about yourself, but thank you very much. So I'm just going to talk a little bit about my research career, which has, followed a very tortuous path. Not surprisingly, as a clinician researcher, hit many potholes and made a bit of progress. So starting out on my research journey, I was in my second year of respiratory advanced training as a physician, and I actually had two wonderful mentors. And I think I would be surprised if that theme doesn't come through in a number of the talks this morning about how important senior mentors are to career development, whether you're a clinician researcher or you're a scientist in the laboratory. And Peter Piggott and Norbert Berend were those people who are now both retired, but were fantastic mentors, both clinically and also from a research point of view. And Norbert Berend actually said to me, here's a study involving animals, believe it or not. I'm not an animal researcher. But he said, I want you to work on this in your third year of advanced training. And somehow found the time as well as juggling a few other roles. And he was really disappointed when I decided to move the family to the UK to undertake my research higher degree. And in doing so, the journey really started because I accepted a job as a research fellow in intensive care in Nottingham. And within the 6 months between accepting that job and leaving to move to the UK, my boss moved to Cardiff and changed his focus. He was an intensivist who did CF on the side. I know it's a bit hard to follow that, but he did. And he moved to Cardiff. And that was fantastic. It was a great place to live. Learned so much about a different culture, medical culture particularly. As an example, we don't think twice about it now, but when I got to the UK, in my first clinic, I had to write up some TB drugs. And drugs in this country, apart from inhalers, and until recently tablets, all had to be separate preparations. They couldn't be mixed together. But in the UK, they were. And I had this drug called Refiner to write up, which was rifampicin and isoniazid. And so there was a lot to be learnt. And fortunately, there was a lot to be learnt because there was no equipment to do my research for a good year. And this is sort of a theme that often happens to clinicians. You either don't know how to drive the machine or the machine doesn't exist yet. So you have to find your time to entertain yourself. And in fact, what I did was learn a lot from patients about the disease of cystic fibrosis. And fortunately, 3.5 years on, I submitted my higher degree for examination, which then sat on the other side of the world, i.e. Sydney, on the dean's floor for 6 months because they couldn't figure out who the internal examiner was going to be. But nevertheless, that happened. And ultimately, it was time to get a real job. And I was lucky enough to do a lung transplant fellowship at St. Vincent's when I came back. Slow learner. That was about my 7th year as a fellow. We were on an outreach trip to Queensland, and I was very fortunate enough to meet Paul Zimmerman, much to the irritation of the transplant service. He then dominated my time in the clinic for 2 hours out of the 8-hour shift to interview me to potentially suggest coming to move to Queensland. And that was probably a really good opportunity, and we did. However, in Queensland, coming particularly in the 90s, you've got to be kidding, you're going to do research as a part of your clinical job. This is a full-time clinical job, and you've got service to do. And very much was told, and it was, that research is done on the side. Despite that, there was a great culture in the department which really helped facilitate and support a fledgling research career. I mean, I think at the immunology session yesterday, one of the things that came across to me was luck plays a role in many discoveries, many careers. And that happened to me because I got this call from someone I didn't really know. And that was Dennis Moss. I didn't realize at all how famous he was, how successful he was. He only ever didn't get one grant in his whole career and was decimated when he didn't get that grant. And I was very lucky to really be brought on as a clinician in some work, some really incredibly innovative work looking at post-transplant lymphoma. And Rajiv Khanna has continued that work. And we were able to develop a new therapy for patients, and it led to a 10-year collaboration. It was really so lucky that that actually happened. As a clinician researcher, one has to embrace the enthusiasm of others because you don't have a lot of time. And I've been very lucky to work not only with research scientists such as Tim, but also a number of other really excellent clinician researchers named here. And ultimately, we were fortunate enough to develop an interdisciplinary aerosol team, which really changed the way we thought about the potential cross-infection in people with chronic lung disease, particularly cystic fibrosis. A real challenge when you work in a hospital like Prince Charles is there's very limited infrastructure for research. In fact, none. There's a little bit now, but not very much. And so you have to go and find, if you've got a clinical question, you have to go and find the expertise and the technology. And that's really exciting, but it does take time and energy. And I think that's something that I think is really important if you're a scientist, is to understand that the clinicians are very time poor. And if they come and talk to you, they must be really excited and really interested about an issue. It also takes a lot of good communication because you're on different sites. And although we can do that by Zoom now, it wasn't always the case in the past. And of course, once you commit to do something, you actually need to do the work as well. So I've been very lucky that our work has been acknowledged through changes in practices in a number of different areas, and also changed the way we think about cross-infection in people with chronic lung disease, particularly cystic fibrosis, and importantly, helped develop the careers of the next generation. And these are some of the people, including 2 of my mentors. Thank you very much.
Oops. Thank you very much, Scott. We're going to have a panel at the end and plenty of time for questions. So it's my pleasure to introduce Professor Peter Soyer. So everyone in this room, I'm sure, knows Peter, but he's a world leader in preventative dermato-oncology. Peter moved to Australia in 2007 from Austria as the inaugural chair and director of the University of Queensland Dermatology Research Centre and a consultant dermatologist at the PA Hospital. He has an extensive publication record and more than 200 publications in the last 5 years and a H-index of 57. He initiated and co-led the Australian Skin and Skin Cancer Research Centre, which is a joint collaboration between UQ and QIMR Berghofer Medical Research Institute. He was co-president of the 2017 9th World Congress of Melanoma in Brisbane. He's the lead investigator of the NHMRC Centre of Research Excellence for the study of naive, and also leads the Australian Australian Centre Research Foundation, Australia Centre of Excellence in Melanoma Imaging and Diagnosis, which is a consortium of UQ, the University of Sydney and Monash University. He's an MMRF Practitioner Fellow. Sorry, he holds an MRFF Practitioner Fellowship and is a Fellow of the Academy, of course, the Academy of Health and Medical Scientists. I've worked with Peter. He is just fantastic to work with, and I'm very pleased to introduce him.
Yeah, thank you so much, Helen. Actually, I enjoyed very much working with you. So I speak about my research journey, and I did my medical school at the Karl Franzens University in Graz, and then in the dermatology department after some clinical work in the periphery. I come from a small town in the south of Austria, the border then from Yugoslavia and Italy. I always compared if I would come from Wagga Wagga, and very proudly, yeah, it's something like this, you know, just a different setting. And I'm very proudly am a graduate of a public high school, right? I mean, in the whole state, we didn't have only one private school anyhow. So just to share, and Graz is, by the way, the #2 city in Austria. I gave my first lecture in Vienna. Vienna is full of these beautiful palaces. It was in '85. I was the registrar. I spoke about dermoscopy, and the colleagues were furious about the presentation because obviously they don't like the concept. I had then my late chairman, he was supporting me, right? He was saying, we do research, not because it works, but we just want to show that new concepts. Very soon after this lecture, I had my first fellowship in New York University. And I was a fellow of this gentleman, Bernie Ackerman, who was basically the world leader in dermatopathology for decades. He, as you see here, he passed away in 2008. Between 85 and 95, I was probably 15 to 20 times in New York, always for 2 weeks, for 3 weeks, you know. And sometimes I feel like this guy from Crocodile Dundee, you know what I mean? The small guy from, or the big guy from a small city in Austria walking in New York, a completely different world. We had to be there at 6 o'clock, that we had this space in the first row, 6 o'clock in the morning, right? This is New York. I mean, they don't have this kind of beautiful work-life balance we have in Australia, right? It's a different world, right? To really sit where I'm sitting, if you recognize me, I had to stand up at 5 o'clock and had to be at 6 o'clock because obviously first come, first serve. This is the dermatology department in about 93 in Graz. You might recognize me. Some of you might recognize Helmut Scheider. And you see very hierarchically, you know, I did make it to the first row, you know. I was in charge for personnel, right? So this was always my part of the game. And obviously, in case you have not recognized me, that's me. The guy next to me, then he became the vice chancellor of our university. Yeah. So I always had curiosity for emerging technologies, right? And this is from the very early time I started. And I don't want to go too much into detail, but obviously in the last 30 years, there was an immense development. Yeah. And I was always involved in international collaborations, particularly within Europe, but just in the field of dermatology, right? And we were very much a kind of an inbred, just dermatologists. Of course, some were then more interested in epidemiology, others more in statistics, but usually they were just dermatology. This is a big difference to Australia. This paper, which we published in 2003 in the Blue Journal, I mean, it's now cited, I don't know, 850 times or 920 times. It's basically, and this led to the foundation of the International Dermoscopy Society, where I have been asked to be the first president, and has impact and guidelines on dermoscopy basically worldwide. I always make jokes, of course, in a few countries less than in others, but interestingly enough, in nearly all first world countries, you know, it's now integrated in the curriculum. Our book, which we wrote, has been then translated into quite a few languages. I'm not sure if I'm allowed to say it has been published into French, Portuguese, Russian, Polish, and Chinese, yeah, and Turkey, you know. So anyhow, and I was always interested in international engagement. I was traveling the world, and you don't need to read this, but just the highlights. I was the scientific director, scientific advisor of the Department of Dermatology in Ljubljana. It's basically 1 hour from my hometown, 3 hours from Graz, capital of Slovenia. And I did it in 2000 also a sabbatical in Rome, but Italian is my second language. Before I came to Australia, my Italian was better than my English. And just to give you an idea where I have been during, and a few places are lacking. I have been recently also been in Chile, and of course in other places around the world. The most exciting visit which I did professionally, I was 3 times in Khartoum. Then it was basically the capital of Sudan. Now it's the capital of still of Sudan, but South Sudan has been demarcated. Would be election its own right, what I witnessed there. Right? I was involved in the training, in the exam of the dermatology badge in Khartoum, Sudan, and actually they're pretty good in dermatology. I think for research, endurance is quite relevant, right? And I always going up and down with my weight. This on the left side is my number 8 marathon. I missed my goal. I wanted to go under 3:30. I did 3:31, but had a negative split. For those who are into sport, means that my second 21 kilometers were faster than the first 21, which happened just one in one of my 8 marathons, right? But obviously I was well trained, as you see. And in 2006, before I came to Australia, I did the Ironman. For those of you who are into the Ironman, with 17 hours, you are not a finisher anymore, right? So I think there were 12 guys after me, you know what I mean, or maybe just 7. I mean, it was quite a terrible performance. Having said this, you can't imagine this, they call it, was the winner party or whatever. There were thousands of people there between 11 and 12 and cheering one on. And it is probably one of the nicest moments in my life. And in 2007, I decided it's time for a change. And I came from the mountains to Austria, to the shores of Queensland. And just now, shortly, you mentioned this already, Helen. I'm really very proud that under the lead of UQ, co-lead with Professor Monica Yanda, we were able basically to form a team between UQ, University of Sydney, Monash, and also a colleague from the ANU. Of course, the critic is, why just the Eastern Seacoast? Why not the other states? We are working hard on this, but I can tell you it's really an exciting enterprise at the moment. We got 10 million from the ACIF against concurrence from Melbourne. Can you imagine? We did beat the guys from Melbourne. And when I heard the names of the other group, I wondered why we won, right? Because these were obviously probably more famous guys in tough team. Anyhow, at the moment we have 10 of these systems installed, then the next 5 will be installed in the next couple of, hopefully to the end of next year. And the really beautiful thing in Australia, and I can't emphasize enough, when we had research meetings in Europe, we were 10 people and we were probably 10 or 12 dermatologists, right? If we have meetings here, we are 10 people, I'm the only dermatologist. Yeah, sometimes the second one, right? But usually we have here this broad interdisciplinary team, and you see it mentioned here. And this is something which, from my point of view, for science is so important. Science is a team sport. There is no doubt, and it makes me angry when people are just judged in their first author or last author. I mean, Fiona, you did a good job with your cell paper. I think you have 7 co-authors. In the days where I mentioned in this paper, we didn't even know that the co-authorship existed, right? But I think you did it very, very well. But science is a team sport, yeah? And this is then basically my last slide. Obviously, what drives us, there are a few things. Obviously, we want to lead the world in this type of research, right? I mean, this is very clear, and We have also now a European Union grant, and one of my postdocs is going very soon now for a sabbatical for a year to Barcelona. So we see the international dimension, but particularly within Australia, we feel extremely strongly about rural and remote Australia. Liz, Monica, and I, we just recently have been in Mount Isa because one of our systems should be installed in Mount Isa. It is not so easy, as you can imagine, right? And not just because of COVID, but this is something where we really feel that the equitable access to health is a big issue in Australia. So thank you so much for your attention.
Thanks, Peter. We'll take some questions at the end. I think you're starting to see the theme of the successful people are collaborators. Science is a team sport. Peter and I both agree that football is the world sport. And you can see from the travel around how that is. It's also my pleasure to introduce Professor Di Eley. Di is the Director of MD Student Research and the MD Director of Higher Research Degree Training in the Faculty of Medicine, the University of Queensland. She's also the Chair of the UQ Human Research Ethics Committee. Di's research career began with a Masters of Science degree in reproductive physiology at the University of Florida. She subsequently worked for nearly 20 years as a bench scientist in biomedical laboratories in Kenya and the UK. In 2000, she began her academic career after receiving a PhD in health and exercise psychology at the University of Bristol. She moved to the School of Medicine in UQ in late 2003. Di is responsible for the development and the implementation of the Clinician Scientist track in the UQ Medical School, which encourages students' interest and experience in research and facilitates medical students undertaking a PhD or an MPhil alongside their medical degree. Thanks, Di. We're really interested to listen.
Hello, everyone. Channel currently. There we go. So a very different talk from me. I'm going to tell you about how to get students, how to work with medical students and get them interested in your research and on the ways that you can be involved in teaching our medical students. So yeah, never let reality get in the way of a good idea, because a good idea is just what I've said. It's important for medical students to engage in research, but the reality is, as all of us will know, is there's a lot of things a lot of humps along the way, hurdles. Not barriers, but you know, you'll recognize some of these, just hospital regulations and just the capacity. But we need students to be engaged in research, and I really would love to hear from and have as many of you, early career especially, to be able to help inject your research and your enthusiasm, how you came into research to our students. Oh, this one didn't get. I thought I got rid of these, but anyway, I'm skipping it through a few slides. So in the MD program, we have 3 basic tiers of research, so to speak. There's curricular coursework, there's extracurricular research options, and then there's the higher degree options, the MD PhD program. So I'm going to just breeze through these, and very happy to speak with anybody later, or we can meet up later if you're interested in this. But if you're not aware that the medical school is going to have a new curriculum next year, I don't know where you've been, because that's been the news for several years. So the good thing about our new curriculum will be research will be integrated into the clinical learning, especially in the first 2 years. And I would really like your input, your team, your lab, you personally, to try and integrate and illustrate, you know, live researchers and live research happening here in Queensland and the University of Queensland into what they're learning. So they make the connection of discovery. Then we also in the curriculum have research options, and those will continue. We have one in year 2 and year 4. Then probably the most common, and some of you maybe in the room have already had experience with this, is we have extracurricular research options. So by extracurricular, I basically mean volunteering, but we don't call it volunteering, we call it unpaid work experience, because that's what Education Queensland wants us to call it. There's rules about everything, and this was the easiest rules to go by. So these are flexible, and I really stress flexible, because these are full-time medical students doing it alongside their medical degree, hence the word extracurricular. But I'm going to breeze through a process that we have that's well established, and it's all hinges around a website on how you can advertise your work. And it could be a small project, it could be a lit review, it could be part of a team, and how then students can inquire about your project. And also, and this is a really, really nice a way for students to engage with you, is you might be talking to a student after a lecture or a talk or something like this, and you know, say, I've got a project that if you're interested, you can work on. Those students that you've made that connection, we just need to know about it. So we have a process that I'll be just breezing through. And just so you know, all of our students as medical students have already fulfilled all these requirements, because that really is an issue for everybody. You know, they can't just go anywhere. So they have all those requirements fulfilled. So this is the website, the student research portal, and I'm just going to click connecting students and supervisors with their research. That's what it does. And so you would go here to researchers and supervisors, and basically this is how to post a project. So, follow what it says here, but I want to just illustrate that what you might want to do is post a project, and then you could find that project on our database, so that you post a project, we approve it, and it goes on a database where you can, the students can come and look at it and inquire with you directly. So you make that connection. You can also, many of you may be interested just in students doing a higher degree. So if you're really just interested in PhDs or MPhils, there's a place that you can also place that, and get a bit more specific student. So here's some reality. It really is very important that we have a mandatory process that students must follow if they're working in any extracurricular research. And that's so that they have UQ insurance coverage for when they're working with you. Very, very important, and I think you'll agree. Now, that doesn't mean that you may also have regulations and paperwork to do in your lab. That's absolutely fine, and we will work with you on that. But it's really important that the students drive this process. We really need to let students understand that research doesn't just happen. It's a lot of work behind providing some sort of an experience for students. And, they have to, if they follow this process, they'll be covered, for insurance, it'll be, mutually beneficial. And so, if you know of a medical student in your lab, or of a colleague that's working with medical students, just ask them, have they completed that mandatory process? They'll say they don't know about it if they haven't done it, but they do. So it's just important to do that. And I don't want to sound like rules police, but if this doesn't continue, it could jeopardize, students doing this sort of work. So enough of that. Just very briefly before I finish, the clinician scientist track started in 2010, and it's still alive and well. We still have the MD, PhD, and MD, MPhil as an intercalated degree. There is no more concurrent work. So I still get a lot of students asking me about that. And then entry is still after they complete year 2. So it's a typical traditional intercalated degree. And they apply to me to improve, to approve them. So, I want to make sure that who we put through will get a scholarship. And then really their enrollment and progression is just like most any other PhD student. And also on the student research portal is all the information about the clinician scientist track. So I just want to leave you with these wonderful, beautiful students that we have. These are our these guys here were shy. They didn't want to put their picture up, but these are all the students that are, as of 2022, are in or have finished the clinician scientist track. So that's all I'll say. I meant to get rid of some of these slides. Anyway, thank you for your support and now and in the future. But if you would like to be involved in anything with medical student research, please get in touch with me. And there's some links there to the portal and the mailbox. Thank you very much.
I'm going to introduce the next 2 speakers, Wayne Nicholls, who's the Director of Oncology Services Group at Children's Health Queensland, Wayne recently is the director of the recently established Ian Fraser Centre for Children's Immunotherapy Research and chair of Queensland Youth Cancer Service Executive Steering Group, and he's the paediatric representative of Statewide Cancer Clinical Network Steering Committee and a senior lecturer with University of Queensland. So come on up, Wayne. And we also have Gustavo Rodrigues Rossi, who is a researcher in the TI squared, is that how you pronounce it? Diamantina Institute, Translational Innate Immunotherapy Laboratory, and his research focuses on understanding the impact of tumor microenvironment mediated regulation of NK cell tumor immunity. So come on up, Gustavo, wherever you are. Oh, there you go.
So thank you. Oh, I thought we had deleted some of these slides, Jeanette. It doesn't look like we did. But anyway, so thank you for inviting us. People often ask me, why did you do pediatric oncology? Surely that's a pretty tough thing, tough gig. And I always say, well, you know, it's one of those specialties that's really worthwhile. But the actual real reason that I do it is because I like children. And children keep you honest. You know, they're very straight and they tell the truth as they see it. And that's wonderfully grounding, especially as you get a bit older. And recently, one of my patients picked up my ID and said to me, "Is that what you used to look like, Dr. Wayne?" Anyway, she didn't have this picture to look at, but that's what she said. So, you know, Queensland is a huge state. Australia's a big country. And we look after all the children with cancer in Queensland and also northern New South Wales. We've gone from, as you probably know, we moved children's hospitals in 2014. And in the last 7 years, we've gone from 180 new patients a year to 250, which is a big increase. And more than 50% of those patients live greater than 100 kilometers from Brisbane. What I feel very proud about is that our Aboriginal and Torres Strait Islander children have the same outcome in pediatric cancer as non-Indigenous children. And that's about one of the only places in health statistics that it looks like that. So as you all know, pediatric cancer is a tiny portion of cancer burden, about 1% maximum, but it's very different to adult cancer. And what we are is a series of rare and very rare diseases. So leukemia and brain tumors are the two commonest diagnoses. And then we've got a whole lot of really weird and wonderful things, mostly embryological tumors of nature. And causes of cancer, what we've learned in the last few years is that about 15% of children will have cancer due to a cancer predisposition. But obviously, unlike adult cancer, it's not environmental causes. But this is becoming an increasingly important area for us to recognize. In most cases, we don't know the cause, but obviously not environmental exposures. However, we're doing pretty well overall for survival, and we've got some real standouts like acute lymphoblastic leukemia, for which more than 90% of children are cured. But we still have what I call problem diagnoses, and that's the ones that I actually happen to be interested in. So that's brain tumors, sarcomas, and other rare tumors that still have poor outcomes. And as I said before, it's not determined by ethnicity, it's determined by a whole lot of other and especially biological features of the tumor. So traditionally, and what underpins pediatric oncology is that we are involved in international collaborative clinical trials. So we have 250 patients. You break that down into a whole lot of rare diseases. So I was saying before, we have about, say, 6 Wilms tumors a year. And we can't do a clinical trial on 6 Wilms tumors, but we can cooperate internationally. So we're part of the Children's Oncology Group, and we participate in their clinical trials. And that's an international group based in the US. It's funded by the NIH. And for example, leukemia trials have seen a huge increase in survival over the decades through those clinical trial processes. So that's the underpinning foundation of children's cancer model of care. Now, children's cancer clinical trials have become extremely complicated as we've got better at curing patients, because to improve outcomes even further, you have to make minor variations, have large numbers of patients, and it becomes very challenging. So we've gone from having, 100 pages in 2000 to having over 500 pages in our standard risk leukemia studies, and very complex arms of study. And this slide hasn't come out very well, but currently we've got about 35 clinical trials open in our Children's Centre for 250 new patients a year. So you can do the maths on that. It becomes complex. You need a big clinical trial supportive structure to do that. And thankfully, we're able to do that. And we have about, 170 to 200 of our patients on a clinical trial at any one time. Now, as I said, we've sort of reached these points of survival with our children, and we understand that biology is actually the answer going forward. We need new ways to do things. And so back in the 2000s, Andrew Hallahan and then Andy Moore set up our Queensland Children's Tumour Bank. Currently that has, and this is really the headline news for all of the researchers in the room, we've got 5,000 samples in that tumour bank of about 1,900 patients of childhood cancer. That's a really substantial resource. And anybody can apply to use that. As long as you've got ethics approval, it is possible to get access to those samples. And I won't go through this because we tried to delete that before. Another big study that's been funded by the MRFF, they've got 54 million from the feds for this, and another 20 million coming in from the Minderoo Foundation, is what's called the 02 project, which is precision medicine for every child with cancer, where they'll be doing complex genomic sequencing, RNA sequencing, methylation arrays, and then in some patients, they're doing high throughput drug screening to determine what might be a particular recipe of treatment for a particular patient. And this currently is focusing on rare and relapsed tumors at the moment, but it will be rolled out to all children over the next 2 years. And that's an exciting step forward. But locally, we've had this wonderful and burgeoning relationship with TRI. Now, Brandon Wainwright, who moved to the TRI in recent years, was one of the founding starters of that with the Children's Brain Cancer Centre that the Children's Hospital Foundation set up. But, and I was telling Gus the story of how the Fernando connection came about. Brandon actually and I met at the lifts in the Children's Hospital one day, and I was telling him about a wonderful presentation I'd seen in Japan about NK cells. And he said to me, oh, I've got this wonderful guy who's just down the hallway from me called Fernando, who's doing NK cell work too. You should meet him. And so we did. And from that, we've had a PhD candidate, Dr. Natasha Omer, working with Fernando and his team on CAR-NK therapy for high-risk medulloblastoma and medulloblastoma. And Gus is going to talk a bit more about that. And as Helen kindly, as was kindly mentioned before, the Ian Fraser Centre for Children's Immunotherapy Research is now finally up and running, and that's led by Professor DU. And more recently, Helen got me involved with the LINK grant scheme, and I think actually Scott was the first one we talked to about that, and he very kindly pointed us in the right direction. And we've just put in a submission for that. So we really see that as a way forward to connecting our researchers, our clinicians with researchers here. So I'm going to leave it to Gus now.
So I'm just going to talk a little bit about our side, the research side. So I'm representing here Fernando. Fernando started the collaboration with Wayne. So Wayne already introduced about the problem. So we want to find cure for hard to treat pediatric cancers. And on my side, everything started with Natasha. I'm also the co-supervisor of Natasha Omer, and she just has had a baby. She's on maternity leave. but her work is to develop a new NK cell-based therapy for treat osteosarcomas. We choose to focus on NK cells for this cancer because after we did this analysis, we can see here on the green line that when you get RNA-seq from osteosarcoma samples and compare the NK cell infiltration, if you have more NK cell infiltration on those tumors, you have an increase of survival of the patients. That's why we want to develop new ways to improve NK cell therapy for those patients. And of course, for research, we need money. Because our collaboration with Wayne, we already got like 2 grants to develop this research in the lab. We also have many other grants applied to study osteosarcoma. And we published a review last year together with strategy that how can we increase NK cell activity to target pediatric sarcomas. And it was only the beginning. After our collaboration with Natasha, we started to develop other projects in the lab. Another importance to have a clinician in the lab, it was because Natasha can guide us, can guide our research. Because like I'm reading papers, everything on the paper looks beautiful. You can find any drug and you can treat the patient with that drug, it'll be magic. But then having a lot of discussions with Natasha, sometimes we come to the lab with these crazy ideas. Let's inject this drug to the patient and let's increase the NK cell power. And Natasha just came to us, no. You can't do that, Gustavo. No clinician will ever inject this drug in a patient because it will be too many side effects or the way to treat the patient will be super hard. So it's amazing to have her in the lab because she can bring to us this clinic side. Like the vision that we have the papers is dramatically different from the visions from the clinics. So it's amazing to have her in the lab. Because this collaboration, we start to have many other projects using sarcomas in the lab. Bronte was our first honors student, and she developed these new 3D models to study NK cell infiltration in sarcomas and killing of 3D models. So here you can see after 96 hours, this in blue here, it's a small osteosarcoma spheroid. You can see the NK cell infiltration, like here you can see on the border of the spheroid, but the NK cells are going inside. And also you can see here an increase of the killing of the target cells. And also we have another honors student that she's gonna finish her honors next week. Hannah developed 5 CAR constructs against osteosarcoma cell lines, and our CARs are working beautiful now. So it was a beautiful collaboration that Fernando started with Wayne, and like it's having a lot of good data in the lab, and hopefully we can translate that to clinics soon. Thanks.
And now if Fiona could come up, she doesn't need much introduction. But she is a fellow of the Queensland Head and Neck Cancer Centre, and her lab program focuses directly on translation of research findings into new cancer therapies, and she'll tell us a bit about that.
How do I get to Emma's Zoom link? Emma's Zoom was in there.
Are your slides after that?
Let me have a look.
Oh.
Emma's Zoom's missing. Okay, I'll talk while somebody's going to find where Emma's Zoom's gone.
No, she's on video, but do you have slides?
It should be embedded in the slides. So I want to talk about clinician science partnerships because I've had a lot of them, and I'm going to talk about clinician scientist partnerships because I've had a lot of them and they've been successful, but they're successful because we deal in reality. So when our clinicians come into the lab, they're not good scientists. They've done an undergraduate degree at UQ, which is equivalent to maybe the first year for my science degree way back 30 years ago in Edinburgh. I did physics, biochemistry, organic chemistry, and I did a PhD in clinical biochemistry at Cambridge. So I'm professionally a scientist. The clinicians are excellent and wonderful, but they are clinicians. And the mindset is completely different. I live in uncertainty. I know nothing, and everything I do know will be proven differently in a week's time. They live in certainty, where they're told to follow clinical protocols and not to alter that, and that what they are taught is the thing. And so we have two different mindsets and two different skill sets, and we have very successfully put those together by recognizing the benefits of both. So what you can see there at the very top corner is Emma, who's just been accepted to the Royal College of General Surgeons, one of the 7% of women in that field, with Jason. They've just done some surgeries of PDXs over an entire weekend. The reason it's over a weekend is because Emma's doing 6 days a week, 16 hours of general surgery at Toowoomba and Dalby. And the last time I saw her, the wall was holding her up. She's very much looking forward to next year because the Royal College have given her a year to finish her PhD, and she's getting to be in the lab. And she's actually got a countdown on her computer to when she gets to come into the lab, because she's pretty burnt out. They're incredibly busy. The amount of work, pressure, and responsibility they take is amazing. Jason is the other part of that project, and Jason's a scientist. And what he does is works with Emma, and when she can't be there, supports her experiments, which is a lot for the science students to take on. But in my lab, all the scientists support the clinicians because they understand the importance of the relationships, and they both learn from each other. So Jason's suturing is beautiful because he learned his suturing from Emma, right? When they go to the patients now, their suturing on the humans is beautiful because they've been doing it on our mouse models. Everybody learns from everybody else. Priscilla, who's a postdoc in the lab and was a PhD student, can do head and neck reconstruction, surgery of primary tumors and flap reconstruction on mice. She learned that from James Nightingale, who's our head and neck PHO. So while Di was talking to you about the MD PhD programs, we actually find that we work well with the clinicians at a stage where they're PHOs, they're waiting to get into their specialities, they're held back, they have to go through their interviews for 1, 2, 3 years. And that's the time when they can come in and do masters or PhDs. Now, both James and Emma started as master's students, but they're both crazy, loved science, and converted to PhDs on their first year confirmations. So Caroline Cooper's in the lab. She's a fully qualified staff pathologist doing her master's. Having a pathologist in the lab is amazing. But our very first experience of this clinically was with Peter Soyer and his fellow Dan Gaffney. And he was our first master's student. We very much learned a lot from that collaboration. Unfortunately, Dan is my only non-completion because he had an undetected congenital heart condition and passed away. So one of the things that taught us is to value everybody around you.
Hello, my name is Emma Carl.
And especially your students in the lab. Can we go back to slides temporarily? Because I'll finish and then Emma's going to be soppy anyway. So then we come to the actual relationships with their supervisors. So I've been very lucky. I decided that I'd put up some photos of all the clinicians that I've worked with. And it was only when I did this, I realized how many it's been over the last 10 years. It's my Pokemon collection, got to catch them all. So on the top row, there are surgeons, and at the end, Jenny Martin, because she's a rare species called a clinical pharmacologist. There's general surgeons and specialty surgeons there. I've learned there's a difference. On the middle row, there are clinician scientists and oncologists like Ranjeni, Peter, Ewan, Walpole. We've got the radiotherapy, oncology guys, Caroline, all the pathologists. What you can see is there's a real mix there. And the reason there's a real mix is that's what we needed to get the job done. So I really like working with surgeons. They're task focused. I was brought up in a farming and fishing community. I really don't belong in this environment, but I do like getting the job done. And surgeons are the same. So I've been working for Ben Panizza for over a decade, trying to solve head and neck adenoid cystic carcinoma perineural invasion. Obviously, it hasn't been that bad. He's just had me put on faculty at the Skull-Based Surgeons Conference in Florida. And I think I'm the only scientist there, and somebody needs to lend me a really small second-hand Armani suit so that I can fit in with the skull-based surgeons, okay? So that's worked very well. We've gone to clinical trial. Ewan Walpole led those. What's really important about this, and we had a discussion about this morning, is nobody here really talks about what the real issues are. And part of the problem for that is perception. Now, this gentleman's in a class of his own. He's David Thiel Sr. I have the utmost respect for this man. He was an excellent surgeon. He was head of hospitals. He has 2 gold medals for swimming in the Olympics for Australia. And he is a gentleman. And somebody like me can go to David Thiel and say, I am completely stuck. At one point in this building, we could not take blood. We couldn't take it at the hospital. We couldn't take it here. We were caught in this catch-22 of health and safety and insurance and regulatory. In a translational building, we couldn't take a sample of blood from anybody anywhere. It took ages. Nobody could sort it out until I walked into this man's office and said, this is silly. And it very quickly got sorted out. And that's one of the things here that is both good and bad. I've had champions, Peter Soyer, Ian Fraser, Ewan Walpole. I have had to have those champions. I've presented to drug companies a set of slides. If I brought one of those gentlemen with me, Peter Sawyer's great at this. He'll be there, he'll put his hand on your shoulder, he'll smile, he understands what this is like. They'll accept what you are saying more. I have been labeled with every possible label through my career here. I do too much publicity. I do too many things this way. I'm not a team player. I'm too quiet. I'm not respectful. I'm too respectful. I'm too loud. I have had every single label you can possibly imagine applied to me, to the point where I no longer care, because it doesn't matter. I mean, I must have like 20 different personalities to fit every label that's been given to me. I had 10 years of struggling through patents and clinical trials and not being able to publish, being told I was rubbish because I wasn't publishing enough. And when I finally published in Cell, I wasn't allowed to take credit for it. But a lot of gentlemen really wanted some credit for it. So we had this discussion this morning where people don't tell the truth. And what the truth we talk about when we're together is that one of the barriers for the clinicians and ourselves is perception. None of us, I feel guilty for having my technology and my patents and trying to get that through for being a woman. Because if Peter Soyer or Ian Fraser had invented that stuff and published that stuff, it would have gotten through 10 years faster. So Emma's going to talk to you about being a general surgeon in the system. She's going to be lovely. She's the sweet opposite of me, right? But I've also, she's lucky, she's got Chris Pike as her advisor, and he's been a champion for her. He's a man who very much places equality as a thing that's needed in general surgery. But some of the things that she's faced in there are illegal, and she will never talk about them because it will risk her career. That's why none of us will talk about it, because it risks our careers. Perceptions in Brisbane need to change, because if you don't choose excellence over perception, then we're going to stay mediocre forever. So I'll let Emma be really nice.
Hello, my name is Emma Carlson and I'm a surgical doctor located at Toowoomba Base Hospital this year. I also have the absolute privilege of being one of the PhD candidates in the Simpson lab at UQDI. I'm really honored to be invited to chat amongst such esteemed speakers today. So thank you so much for inviting me. I also especially appreciate being able to present via Zoom from my room in breast clinic. So our collaboration began when I met Fiona at the end of 2019. I had approached my surgical mentor, Professor Christopher Pike, to see if he had any opportunities for me to become more involved in research. Clear as day, I remember him saying, there's a brilliant but fiery professor at UQ that I think you'll get on with. And he couldn't have been more correct. Fiona interviewed me over pizza at UQ, and she actually had brought along her son as she had to pick him up after jiu-jitsu. And I remember her stepping out to take a phone call, leaving me and her son alone to discuss science and the world. And to this day, I still feel that that was secretly the real interview to see if I was the right match, personality-wise, for the lab. And I think that's the main point I'd like to make today. Overall, I believe that true collaboration and translational research is underpinned by respect and the right combination of personalities. In my wildest dreams, I still wouldn't have Fiona's phenomenal grasp on biology and the way our cells work. I am constantly in awe of her knowledge and creativity, which is built on decades of hard work and scholarship. She is constantly brainstorming and hypothesizing 10 steps ahead of me while I'm still fumbling through the science textbook. But at the same time, every Wednesday, I'm the one who clinically meets with about 50 women in breast clinic, and I have real lived experience on what troubles them and what their healthcare concerns are. And I know what it's like to perform a mastectomy. I know what it's like to get a physical specimen that we get out and analyze under the microscope. And I believe that Fiona respects that and respects the perspective and point of view that I bring to our collaborative relationship. And this combination of trust and respect, I feel, allows us to fill in each other's gaps and make our scope for change twice the size. So learning to be both a scientist and a clinician has been really exciting in the lab. And one of the main things I enjoy is how different the two working environments are. At the hospital, I'm currently assisting in a trauma job, which is quite fast-paced, bright, high intensity, and requires protocols and algorithms in order to rapidly triage and treat critically unwell surgical patients. But at the lab, I'm usually in the microscopy suite, in the dark, tinkering with exposures and taking my time to decide on what's the best way to complete the next part of our experiment. It's really methodical and organized, and I'm sure most people naturally tend to lean to one side or the other, but having both in my life has been really exciting and lovely, and having that side being brought out by Fiona has been really lovely. And with the good, there's also bad, and I think it's important to understand and be cognizant of the real barriers that exist in collaboration between clinicians and scientists. The healthcare industry is not known for its lifestyle-friendly working hours, particularly general surgery. And doing both a surgery and a PhD is technically difficult and only really possible through exceptional people and their flexibility. So just to record this talk today took an exceptional amount of work from both TRI staff, but also my surgical consultant to let me duck out of breast clinic a few hours early. So I think that flexibility and respect and consideration for other people's working commitments is vital to running a collaborative and translational research lab. So not only flexibility on a lower level, but if we think about it on an institutional level, I think that more could be done to promote and facilitate clinician scientists and also translational research. So what if we formed true collaborations on like a Metro South TRI level to create clinical jobs which have FTE rostered to research work? I think that this could be a really great opportunity for junior doctors to have real lived experience in the clinics, in the operating theaters, but then also have dedicated time to be researchers and to engage with the labs that we have here at the TRI. I think that there's a lot to consider. I think that there's so much that is already being done so wonderfully that I think we have a lot of space to move and improve going forward. So I'll leave the remainder of talking to my better half, which is Fiona. But thank you very much for the opportunity to present today. And I would love any emails or questions from anyone who's interested. Thank you very much.
Thank you, Emma. If we could, yes, if you'd like to give her a clap. We will finish by 10:15, but if people could just quickly come down for a 7-minute panel. Has anybody got any questions for anybody? Perhaps we could think about Emma's last point, which is how we can improve engagement and the environment for clinicians to engage with scientists. Oh, it's working.
It's an age-old problem, and the health system basically supports clinicians. And the way health is funded in Australia, where clinicians will earn even more money if they go and work in private than they do in the public system, just means that there's this great pull of clinicians out of research rather than push towards it. It's very different to the American system.
And different to the European system, which I can just speak about Austria, Germany, Italy. Our university hospitals have just one employee and all doctors are employed by the university, full stop, right? And then the chairman of the respective department, basically based on the individual excitement and output of research, provides more restricted, protected time for research for some people than for others, right? I mean, it works actually pretty well. And what makes me crazy, if some places like are called university hospitals and they are not, right? And this is really a lip service. Other places like the North Side and here, we are university hospital. And actually, I know from some departments that really the director of the department say, you know, you are doing such a fantastic research, you have protected time. And this is in the ingerences, we say in German, of the director. Having said this, I know it from down south, from Sydney and from Melbourne. If you want to be to get a registrar of position, then or a consultant position, you have to have a PhD, you know. And then sometimes they are making jokes about Queensland, yeah, that we are a little bit behind, you know. I mean, this is a reality, yeah. And I obviously see it with a different mindset because I have been primed in the European system. And I can tell you, look at the Charité in Berlin, look at the AKH in Vienna, look at the University Hospital Tübingen. All these people do the research within the clinical time, as they do, by the way, in the States. This has, of course, historical legacy issues, less competition in Australia. But having said this, in the decade which I'm here now, 15 years, I see a shift. Yeah, things are changing, and everyone knows cultural changes takes time, but it is happening, right?
Di, can you project forward what you think the curriculum change is going to do for the future doctor?
Right, thank you. Well, with high hopes, first we're going to start with getting our students when they graduate from medicine to be research. Think of a word, I'll choose literate. So, you know, all our medical students are not going to become researchers or do PhDs, but we do want them to understand research and be able to use it and be better clinicians. And I know that sounds a bit cliche, but it is true. Now, what would really be ideal, and especially for the MD PhD program, is if they finish graduating for their MD and their PhD, they go into protected time. That doesn't happen. And I have a hard time often encouraging these just unbelievable students, you saw them up on the screen, to do this, to do a PhD. They say, when is the best time? And look, I don't have either. I mean, I've got a PhD, but I couldn't tell you when the best time is. The best time is when you can do it and do it now. But what a waste if they have a gap from 3 or 4 years until they actually get into their clinical space. And it's also, it's time wasting, and we lose a lot of students that way. We lose a lot of PhDs, productive MD PhDs.
Yeah, and I think there are a lot of people who realize when they're doing their advanced training and they start to do projects and they get into it, and then it's kind of very difficult for them to break, and they need to get a job and they go into private practice, and there's no alternative path to just take a year and do some research or a bit of part-time research with the funding of that protected time. So I think that's really critical.
There are some, it's starting very small. Melbourne has started a small
Correct. We
pilot.
need it here.
Yeah,
Yeah.
let's fingers crossed, everybody.
Yeah. Anybody else want to?
Oh, look, I think I think I've got one here. So there's no doubt that my career was really helped by one of the Queensland Health Fellowships, which brought out 2 days a week for 2 years, 5 out of the 5 years. The problem is if you're in a very specialised area, getting backfill is really challenging. But I would also make the point, don't give up on it all, because there are many clinicians that will work with you above and beyond their clinical job. So don't wait for the cultural change. There's still great opportunities. People can do it in full-time jobs and get you samples and collaborate with you and meet with you. You do need to be flexible though. Don't expect that you will always be able to have that meeting at 9 o'clock in the morning.
I think also as scientists, reach out to people. If somebody said, if a clinician comes and talks to you, might have been you, who they're really excited about what they want to do. So take hold of that and take the opportunity and be flexible about, okay, well, do you want to, you've done some research, you want to finish the MPhil and I'll co-supervise you while you're at Ipswich and we'll be on Zoom. I think make the opportunity happen for people, because they really do appreciate it, and they remember they become collaborators for the rest of your career, very useful collaborators. Yeah.
I completely agree that for the clinicians, getting time to do the experiments is really hard. But we also need to focus on the fact that they have to have young scientists in the lab to support them. And we've just seen this with the Link grant, where we were contacted by about 10 young clinicians interested in putting links in, and we couldn't find enough postdoctoral scientists to match them. Because while everybody's been focused on the translation, what we haven't realized is all the science postdocs are disappearing.
Yeah. Yeah.
And there's nobody to train the clinicians to be scientists without a postdoc. So the balance has to change, but it also has to be right. Because we can't run labs with clinicians in part-time positions who are not scientists trying to do the experiments with no scientists there to support them. It's a partnership, and that has to be recognized.
That's a very good point. And in the UK, they now can't get people to fill good academic positions because there's so much industry pull for the scientists out of the labs, and the salaries are much higher.